Hi everyone. For today's warm-up, go to Canvas and download this, or print it if you'd like to write on it. Complete questions A through D, and then unpause the video to come back. You're using your notes from last class to complete this warm-up. All right, so to go over this warm-up, we asked for the shape. Remember, that's approximately normal when n times p and n times 1 minus p are at least 10 for both samples, seniors and juniors. I like to label them, keeps it organized for myself. The mean is the difference in the sample in the population proportions, so show your work there to get that. Standard deviation is the formula from your formula sheet, and it is square root P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. Remember, the interpretation of standard deviation is the typical variation from the mean, and so just have to put that in context. And then letter D are finding the probability, and so we do our normal calculation since it was a normal curve. We have our mean and standard deviation that we'll use to label the curve, find the z-score, and use table A to get the answer. So if you have any questions or problems with this, make sure you ask your teacher for a little clarification. And we will move it right along to the activity. So to access these population scores, go to https. You can just go to bit.ly/ACT scores-U5D04. Case sensitive to view the population data yourself. And so what you're going to do is use that data to get your sample of 4 students to calculate the mean ACT score for that sample. So what I did is I just, first of all, you're going to describe the population distribution here on number 1. That's the 100 scores are all plotted right there in the graph right above number 1. And then on number 2, you'll use the data from the bit.ly and a random number generator. You can use your calculator, or I just Googled random number generator, and you'll just pick numbers from 1 to 100. You'll pick 4 numbers and find the ACT score that goes with each number, and then find the average ACT score. So make sure you use the list of data to find the ACT score that goes with the number the random number generator gets you. Do 4 numbers at a time, find the mean of the 4, and then repeat that 5 times. We'll enter the class data together into a collaborative dot plot, but if you're not in class and this is you watching this video at home, or you weren't there for the Zoom that day, then you can just copy down the dot plot that we use when we go over the activity. So I'll show you what that looks like in a couple minutes. If you are here, if you have the dot plot already, just go ahead and answer questions 1 through 5. And if you're not here, you can use this. If you weren't here, you can use this data to answer the question. So I just picked 4 numbers from the list at a time, found the average ACT score, and then we plotted the class data together. It's just a rough sketch. So you can go ahead and copy that class data down and then answer questions 1 through 5. Pause here. Okay, so for the shape for number 1, I want to label this as the population distribution. And then I didn't fill in number 1, but I'm going to label the population shape. Looks approximately, well, they told us that, well, they didn't tell us. I'm going to tell you it's approximately normal. We have the population mean is mu, that's 23.2, and the population standard deviation sigma is 5.025. So remember, those are population parameters. And then we're just going to label each one of these. And remember, like this particular, let's look at this particular value right here. One person got a 35 on the ACT from Pindaland High School. That's what that 1 dot means. And then when we look at each of these are different values, what they got, and these are X bars. Remember, X bar is your sample mean. So it's the mean from a sample, and our sample size is 4. We have 4 values in each sample. So let's check out the sampling distribution of X bar right here. So I'll just look right here at this value right here. One group of 4 average 2, and that was like, 29.2 or something like that. 2.5, let's say. And so that is what that dot represents there. And so that is our dot plot, which represents, because it's a sample, because each dot has its own sample, then this is the sampling distribution of X bar. Now we didn't find all possible samples of size 4, because there would be a lot more than this, but we did a lot. So it's part of the sampling distribution. Let's talk about the shape, center, and spread. With the shape, it looks about approximately normal, looks similar. So the shapes are going to be similar. If the population distribution is normal, then the sampling distribution is normal. And we'll learn one more rule for the shape as well, so that's great. For our center, notice how it stayed about the same. And so it should be exactly the same. We're going to say mu of X bar equals mu. Remember, it's an unbiased estimator. So the average of all the sample means should equal the population mean as well. And it looks like my standard deviation got about half as large. If you look at the range, it kind of decreased by about half. And so the formula that we use for that is the standard deviation of X bar equals the standard deviation of my population over the square root of the sample size. And so if we actually do that for this problem, 5.025 over the square root of 4 is about 2.5. And so that's what we should be seeing there. That works out. And we would still check the 10% condition for this standard deviation. And we sampled 4 people. There were less than 40 students in the class. And so we'll still keep that up. And then we already know that as standard deviation, well, as our sample size goes up, our variability will go down. So basically went from a sample size of 1 for the population to 4. So that's why I got smaller. You can see algebraically how that works as well. So that's pretty much sampling distribution for sample means. This is our third kind. We have one more to learn, but before we get there, I want you to pause the video here to take notes. Remember, we have quantitative variable this time. Means are for quantitative stuff that you can calculate an average for. And we have the parameter and statistic symbols that are really important. The formulas for mean and standard deviation of the sampling distribution. We still check the 10% condition. And the shape is approximately normal when the population is normal, but there's also one key thing here that this activity doesn't get to show. We don't have time to show it in an activity right now. And that's the central limit theorem, which we call CLT. It's very easy to remember since we live in CLT. And so that is what we will use if our sample size is at least 30, then we can use this to check the normal condition as well. And so 30 is the sufficiently large value that we use. And so go ahead and copy all of this down. Here's the formula for z-score. It's value minus mean over standard deviation. And it just substituted the symbols for for means on this. And then you can try to check your understanding. Okay, so here's the check your understanding. It starts off pretty simple with just one value, just a regular normal problem. So the probability that a randomly chosen pregnant woman has a pregnancy more than 270 days. And this data is what this problem says, and the data we used in our midterm review was from other data. It's probably just different years, different lengths, but 266 is the average here, with standard deviation 16. I think this one's kind of old. Hopefully, or else maybe I'm not here for this video right now, and maybe I already have the baby. Anyway, number 2, the formula for mean is just the mean. Number 3, the formula for standard deviation is the population standard deviation over the square root of the sample size, so it gets a lot smaller. I checked the 10% condition and interpreted it. Remember the typical variation from the mean. My number 4 didn't show up, but it should be on your paper to find the mean length of 6 women is greater than 270, and so here's all my work for a normal calculation. It's really all the same stuff. It's just the main thing is the difference in the symbols. So what you guys have to remember is that we have P hat is our sample proportion. P is our population proportion. Mu, well, let's do it in the same order. X bar, sample mean. Mu, population mean. And sigma, population standard deviation. And then any sort of subtract or add, or any sort of subtraction is a difference in the two. We'll do differences and means next class. All right, hope you guys have a great day. Check Canvas for what to do next. Thank you so much. See you soon.